Thanks, David. So as David said, I'm Adam McGough. I'm the head of data science here at M Brown. Before I jump in, I just want to say thanks to Data Idols for hosting us today and letting us come along and share a little bit of our work with you. It's actually one of the big reasons we work with Data Idols when we're recruiting roles in the team. The fact that they invest back in the data community and arrange these events for us all to come together and share our knowledge and learn from each other. So thank you. I'm also going to shamelessly plug that we are currently recruiting a couple of roles in the team. So we're looking for a senior data scientist and a machine learning engineer. So if you are interested in either of those roles, just get in touch with one of the Data Idols team. So we're here today to talk about customer value modeling at M Brown. Before we jump into the project, I'm just going to spend a few minutes introducing M Brown to you and the incredible data science team that I'm very proud and very privileged to work alongside each day. So M Brown's, as David said, is one of the UK's largest fashion retailers. It was established in 145 years ago. And it's a pretty fascinating company because right from its inception, it was one of the great innovators in many of the areas that we take for granted today. So it's actually one of the first UK retailers to send customers orders through the post when the post office parcel service was set up in the early 1880s, comfortably 100 years ahead of Amazon. And we've been sending orders that way ever since, adapting as technologies evolved from horse and carriage to catalogue to phone to computer to app. That business model means that throughout our history, we've gotten to know customers that we've never met. And so we have throughout our history gotten to know customers through our data. And that rich data heritage permeates through the organization in the richness of data available to us as data scientists, in how data is recognized in our organizational structure and in how people think and act with data. Today at M Brown, we've got a data community that's over 100 strong. We've got a team of 30 centralized data scientists, machine learning engineers, and data analysts who work together in collaboration on projects that span the organization, from churn modeling to price optimization, from natural language processing to recommender models, and indeed customer lifetime value. What we actually work on is really guided by where we can get the greatest return on investment of our time. And that's one of the 3 principles I've called out on this page. Hire right. At the end of the day, if we hire brilliant people, everything else falls into place. So for us, that means hiring the curious. In the team, we've got bloggers and YouTubers, computer builders and just for fun modelers. We hire people who have a passion for data. Dream big. We're in a privileged position at M Brown. We work on some of the biggest opportunities ahead of us as a business. So it's really important that we think big and be ambitious in the change that we can enact and deliver value. Again, just making sure that we get the greatest return on investment of our time. The project that we're sharing today, I think it does a brilliant job of working across those principles, and a lot of people across the organization can take credit for it. I've got 3 of them with me today, cutting across the specialisms that I've talked about. And they're going to share their experiences in delivering what's been a huge and complex project. And in doing so, I hope give you a sense of some of the philosophies and some of the technologies that we use here at M Brown. So without further ado, I'm going to pass you to Laura, who's one of the lead data analysts in the team and can take a lot of credit for getting this model embedded across the organization.
Thanks, Adam. So hi, everyone. I'm Laura, and I have worked as within the analytics area at M Brown for just over 3 years now. And a key focus of my role has been delivering what we're going to talk about today. So linking back to what Adam said about how within our team we like to align our resource to the biggest opportunities within M Brown, we feel that this project that we're talking about, we delivered on all our 3 rules for success. So hiring right, dreaming big, and delivering value. But first of all, let's have a look at how this opportunity arose. So I'll refer back to our annual report from 2020, in which our very own CEO, Steve Johnson, cites that an appropriate cost base is key to building retail profitability. And he cites that through a benchmarking exercise that we undertook, we'd identified that our marketing expenditure exceeded that of our peers. Now, that's not going to be a problem that will be unique to us. Many companies will also face that challenge. But the key to rectifying that is having the understanding and the clear data to be able to measure value and where good recruits come from so that we can improve our marketing mix and efficiency. So our approach to tackling this problem has taken 3 stages. So first of all, we needed to be able to identify who our most valuable customers are and where they came from. And we've been able to do that because of our really comprehensive data assets. And I'll come back to that shortly. The next stage has been to take those historic values that measure the customer value and use those to predict who will be the most valuable people to us going forward and where they've come from so that we can allocate resource. And then finally, working collaboratively within our team and also with stakeholders from around the business, in this particular case, our colleagues within our paid marketing teams, marketing media teams, who will allocate spend against our paid media channels such as pay-per-click, display advertising and paid social. As a group, we've used the insights from this predictive modelling exercise to make changes to our marketing spend and really drive efficiencies and the mix that we've employed in our marketing. But before we can do any type of modelling exercise, we need the data that accurately reflects what value means to us as a business. And we also had to define what value meant to us. So to do that, what we undertook was an exercise of mapping out our business model. And the graphic that's shown on the screen at the moment represents how value flows throughout our business. And what I'll do is I'll take a quick walk through this because I think it's really key to understanding this, to get from the conceptual, how the business works, down to where the value is, and then apply the data assets that really brings this to life and means that we can measure accurately. So if we start at the top, we have our customers. We have new customers coming to join us, and we also have a very loyal base of existing customers, and they all place orders with us. And by that, we then take that value and we term that demand. So any of the receipts that we take through our various channels, through desktops, apps, mobiles, these customers have come through us through a variety of marketing activities. We take that demand. What we then need to do is take off and look at all the different things that might happen after that. So some of our customers will return items to us, and some may even cancel their order before they actually receive it. We also need to factor in our VAT bill, unfortunately. And we also need to think about the income and costs associated with postage and packing. So that red line there represents data that we've had to source to accurately define that. So once we take that off, we then move from demand to a net revenue position. By that point, some of our financial services customers, and these are customers who've chosen to take advantage of our credit offering, whereby they can spread the payment of the items that they've chosen to purchase from us over time. Some of those customers will have started paying us interest. So we can bank that within the revenue. The story doesn't end there though. We've also got other costs that we need to consider. So we've had to purchase the items that we then sell on from our suppliers. So we need to take our cost of goods sold off from our product revenue. And there will be a small minority of our financial services customers who may have had trouble paying us their interest back. And that takes the form of write-off. So we do need to take a small amount off for that. So by this stage, we've got to margin. So we're getting closer to profitability and value. But there are still some costs that are across all customers that we need to apportion. So all the previous costs have been more associated to the individual item purchased. The next layer of costs are allocated across the whole customer base, depending on how customers behave. And these cover things such as our admin costs, our costs of running the call centre when people have queries or may want to order, and our marketing costs. So we've undertaken analysis to determine the best way to allocate those costs across our whole customer base. And finally, once we take that off, we get down to what we call total contribution. And that is what we've used in this modelling project to determine our value. The development and improvement of this data source that accurately reflects what value means to us has been a fantastic piece of work undertaken by our finance department, and it's been improved on over several years. The level of understanding is so granular, it covers every item purchased by every customer. And it's become a trusted and recognised source of information throughout the business, having been reconciled against our financial accounts and also signed off by our CFO present at the time of its inception. This data source is so valuable that it underpins a great deal of our machine learning and modelling work, as I say, because it covers every item purchased by every customer and spans several years. So now that we can truly understand and, more importantly, measure accurately this value within our data, I'll hand over to Jane, who will explain how we've used this data to turn it into predictions.
Thanks, Laura. I'm Jane. I'm a senior data scientist at Brown, and I've worked here for 2 years. And so before going into the technical details about how we predict customer value, I thought I'd just kind of explain the guiding principles for building models within our team overall. So we aim to do it in 3 steps. We make it work, we make it better, and we make it fast. So first of all, we build a relatively simple model targeting a specific use case to make it work, to prove that we can get value out of it. And then from that, we then improve it, we make it better, we apply it to more use cases, and we really get value out of that model. And then finally, we have the 3rd step, which is make it fast, which is what Nikos will talk about in his section on engineering later on. But first of all, I'll just talk through the first model that we built, so the making it work phase. So to build this first model, we focused specifically on new customers, and we looked at keeping it relatively simplistic by predicting the long-term contribution of new customers. And so what this allowed us to do is this allowed us to look at where we were spending marketing spend to attract these new customers, and to assess whether these new customers would be more profitable or less profitable, and it allowed us to allocate that spend more effectively. Now, actually predicting the pound value of contribution for each customer is quite difficult because of the extreme values. We have customers that may purchase loads with us, but unfortunately get into financial difficulties and write off. And it's those kinds of extremes at either end that make it quite difficult to predict value for a single, with a pound value attached to it. So the approach that we used was actually predicting the rank of the customer. So predicting the percentile of where the customer would be amongst its peers against the actual. So we predicted where we thought they would be. So if the customer would be in the top percentile, for example. And then using that ranking, we could map it to a lifetime value that helped us understand the profit that they drive. Now, on the right-hand side, we've got a heat map. And basically on the y-axis, we've got the predicted percentile. On the x-axis, we've got the actual percentile. And what you can see here is that we've got a strong pinky blue line through the diagonal, and that's what we want. We want to be able to predict the rank of our customer well. But we also have two interesting pockets. So we have nasty surprises and blessings in disguise. And these nasty surprises, this is where we've predicted that a customer will do well for us, but for whatever reason, they actually end up being one of our worst customers, and that's likely because they've gone into to write off their debt. And then we also have blessings in disguise, and this is the opposite kind of story. So these are relatively high risk customers that actually surprise us and go on to bring us a lot of value and drive a lot of value for us. So that's how we tackled it initially for this question about new customers. But ultimately that left us wanting to make it better, having lots more questions. And so I'm going to drop in an analogy to Greek and Roman mythology, because that's what you want from a data science talk. And basically it became like Hydra. So in Greek mythology, Hydra is this monster that has several heads, and once you chop off one of its heads, it grows two more in its place. And that's kind of what happened with the initial model and generally in projects, is that we answer one question, but we're left wanting more. So what came out of this was that we were asking, okay, so we've got this single prediction of contribution that we think is assigned to this customer, but where is that coming from? Is that coming from returns? Is that coming from a high cost base? Is that coming from interest? Is that coming from the overall demand? Why is that? Why have we got that prediction? So that was one question that came out of it. And then a second question was around existing customers. So currently the first model was just for new customers, but we wanted to understand our whole customer base. That would help us with demand forecasting, for example, and also just help us understand our overall customer base. So there were a lot more questions that were coming out. And so to talk about version 2, the make it better stage of customer value on the next slide, I'll just talk thanks. So on the second version of customer value, what we have is, this is completely dummy data, but this is to show the journey of a customer. So a customer will come to us, buy some products, return them, pay delivery charges, pay VAT, etc. And then if they're a credit customer, they might pay some interest, or they might write off, and then we'll end up with a value for contribution at the end. Now, the second version of the model, we want to really understand what is building up to this contribution value. So we're now building out these individual parts, and it becomes a much more complex model, because now we've got to think about demand and how that relates to the customer and understand that separate component. And then there are also other components of the modeling process which could argue are definitely simpler. So VAT, for example, is just a straight 20% of demand minus returns. So the version 2 is building out the individual components of this customer value, and some components are simpler than others. So because I can't talk about the whole model this session, I'll just talk about the demand model specifically. So the demand model, so the histogram here, what this is showing the number of orders that are placed by our customers. And what you see is there's a peak around 0, which shows that a lot of our customers in the customer base don't purchase with us again. Now, this distribution follows a zero inflated negative binomial distribution. And what this is actually a combination of two processes. So the first process is a binary process, and we're asking, okay, will a customer order? If they do order, then they go into the negative binomial count process, and that is a prediction for the number of times that they will order. So we have a separation of different customer groups there. We have some that will definitely not order, and some that will order, and we're trying to assess, trying to predict how much they will order. So taking a step back, if we wanted to just predict this straight away, what we'd actually end up doing is under predicting, because it would just try and predict all of the non-orderers, because they're the majority of the customers. But what we actually are interested in is the customers that do go on to order. And so we want to be able to separate these orderers from the non-orderers. And so the next slide, I'm going to talk about how we're actually filtering off these non-orderers. So the first step was that we predicted the order probabilities for each customer. So we were predicting the probability that each customer would order again. Then we fitted a zero inflated negative binomial distribution to the observed data. And this is what the results are shown on this slide. So what we have here is the different parameters of that distribution. We have on the left-hand side the distribution of those parameters, because there's uncertainty around those. And then on the right-hand side, this is showing the sampling process to find these parameters in parameter space. So we used PyMC3 to use Bayesian statistics to update week priors, get those estimates of the parameters, and also understand how they're actually distributed. So now we've isolated the parameters that generate the negative binomial part of that zero inflated negative binomial distribution. So now we know what parameters we're looking to find. Can we map that back to the order probabilities and use that to separate these customers into two groups? So that's what the results are on this slide. So on the left-hand side, we found a threshold which, if a customer was scored with a probability less than that threshold, they would generally be non-orderers. There are a few cases where they did place an order, and that's because of the fact that the probability model isn't perfect. But on the right-hand side, what we have is a negative binomial distribution of the customers that have placed orders and that are above the probability threshold. So we've nicely separated out these two customer groups, and that helps us to model in the next step. So to recap, what we have is a customer with a predicted order probability, and then based on that order probability and based on the threshold that we've identified using PyMC3, we can separate these customers into different demand modeling processes. And overall, what we found is that approach improved both root mean squared error and net error compared to a single model. Now, even though the final prediction is really important, that's super important, equally important is actually understanding our models, and we can get a lot of value out of that. And so on the right-hand side, what we have here is a SHAP plot to explain our XGBoost models. So what this is showing is the kind of the value of the features that are resulting in the final prediction. So in this example, we predicted the output of the model was 4.346, but one feature contributed 0.6 to that. And so this is really key in our model development process and evaluation, because we want to make sure that first of all the predictions make sense, and that also that the features make sense. But this can also help us understand our customers. It can help us understand what makes them more likely to order, what makes our customers more likely to order more. And so it's really important that we also make sure we understand our models. Now, that's just one model of the sequence. So I'm going to now take this opportunity to hand over to Nikos, and he can talk about the engineering that facilitates all of these models working together.
Thank you, Jane. Hi, everyone. I'm Nikos. I'm a machine learning engineer in the data science team at M. Brown. And I've been in the team for around 2.5 years. And I'm currently focusing on productionizing the customer value model. So from an engineering perspective, productionizing a model like customer value was quite a challenge, as we have a lot of models and different processes with interdependencies between them. But in our team, we have the technology to handle this. So over the last 2 years, as a data science team, we moved to working on our model cloud data science platform. And at the core of our platform is Amazon Web Services, where we use S3 as our data lake, Athena for querying our data from the data lake. We are using Amazon SageMaker basically to remove the heavy lifting of our machine learning process and to make it easier to develop high quality models. We also use SageMaker as our central point of our work, where data scientists build and train and tune the models and collaborate with machine learning engineers who deploy and manage the models. Also, we use Amazon ECR as our container registry service for storing Docker images. And we use also CloudWatch for our metrics and logs repository. However, our toolset doesn't end in AWS services. And in fact, we benefit from several open source technologies. Generally, SageMaker allows us to integrate custom code, to integrate models or other open source tools. So we use open source libraries like scikit-learn, XGBoost, and TensorFlow for model building. We also take advantage of other tools, for example, to help us to work in higher standards. For example, GitLab for version control. We use Docker for reproducibility, portability, and easier deployment. We use Jenkins for our ops-related tasks and continuous integration of our models. We use Airflow for batch orchestration of our models and our processes. And also we use Elasticsearch, Grafana, and Kibana to analyze our logs and monitor our processes. So these are the tools that allow us to build and deploy into production high-quality data science products and to deliver value for the business and our customers. And now I would like to give you a high-level overview of the approach we follow in order to productionize the customer value model. As Laura and Jane explained earlier, the customer value model is quite a complex model, as it consists of several individual components and models and different processes that we need to orchestrate into production. So our key principle and aim is to have a deployment workflow that is reliable, repeatable, and robust. And we are based on engineering and MLOps best practices. And we do this through the end-to-end flow that you can see on this diagram. But before moving on it, let me first highlight that deploying a model like customer value is not like taking a recipe and implementing it in production. You know, unlike Avengers, you cannot go alone wolf like Iron Man. And generally, machine learning is a team sport. And actually, you know, it's not only one activity. There are different number of activities and workflows that are chained in a pipeline and towards a specific end, which are the model deployment and delivery of the results to the end users. So generally, deploying the model into production requires a lot of collaboration between data scientists and machine learning engineers. And In our team, we have embedded collaboration into our ways of working as well as in our systems, something that allows us to deliver and deploy high quality end-to-end data science products. Now, I will go through the end-to-end process using as an example the demand model that Jane explained earlier. And all starts from SageMaker, where data scientists and machine learning engineers collaborate and build their code. And when all the code required for running the model into production is ready, and all the tests for ensuring that our code is doing what we expect it to do are also ready, we push our code to GitLab. And then Jenkins gets into the game. So Jenkins automatically clones the code from the master branch, and it builds our Docker images, run automatically all our tests, and it builds our Airflow production pipeline, which is the actual pipeline that run our models. And also Jenkins moves our production pipeline from the development environment to the quality assurance environment for testing. And finally, if all the tests are successful in the QA environment, Jenkins pushes it to the production environment. Overall, this architecture allows us to build new models, to build new features or update existing models and deploy them rapidly into production. And it allows us to thoroughly test each step of the pipeline individually in different environments for ensuring reliability. But now, when we have our machine learning models into production, it is highly important to ensure that they run correctly, and as well as that they produce high quality predictions over time. And it is very critical to set up a process that monitors things like errors or latency, but most importantly, to ensure that our models are maintaining a predetermined desired level of performance over time. So in general, machine learning models learn relationships between inputs and outputs from historical data. And since the real world is dynamic, those relationships are constantly changing, something that can have impact to our models. So in our production processes, we use a custom logging framework and Airflow to provide an automated monitoring of our models and also of our infrastructure. In terms of infrastructure, we monitor things like the memory usage, CPU and GPU usage, etc. And in terms of machine learning models, we monitor the quality of data feed into our models. We monitor the modeling assumptions and also the stability of our predictions. So to wrap it up, our deployment pipeline allows us to deploy into production continuously and securely and quickly, avoiding the gap between development and production to opening up. And it also provides automated monitoring for each step of the pipeline. And overall, it allows us to productionize complex models like customer value model and deliver value to the business. That's an engineering overview of the project. Now I will give the floor to Laura, who will talk about the application of customer value model.
Thanks, Nikos, for giving an overview of our pathway to production. So now we've got all those productionized predictions, how have we used them to best effect? So if we recap, our area of focus was to drive efficiencies within our marketing spend. And we've achieved this by developing what we term at M Brown our marketing investment guardrails. So what are they? These output the boundaries at which further investment would be unprofitable for us. So therefore, we're always aiming to be operating above this level. I'll try and explain this in a different way. If we have a look at the graphic on the left, what we see here is what we term our return on investment, and the dotted purple line is our guardrail level, and as we can see, our orange line is above that. So put it another way, for every £1 that we spend in marketing activity, the return on advertising spend guardrail tells us the minimum level of return that we need to get for that to have been profitable investment. And as we can see, we have been operating efficiently and above those levels. I obviously can't divulge the inner workings of how we get to those values, but the wheel on the right will cover some of the key components. So first of all, powered by value, what do I mean by that? Well, we've moved from a situation where short-term outcomes were driving how we determined our marketing spend. And now customer value predictions are an embedded part of our marketing planning process to ensure that we're delivering value not just for today, but for the longer term as well. Flexible, these guardrails or the outputs of where we should be spending to are flexible, and we can determine things depending on our current trading environment by adapting the importance of a particular metric at a point in time. So at some stages it might be more important for us to be recruiting new customers over getting more demand in through the door. But what the guardrails do is ensure that we only invest to a point where it is profitable and will drive value for the long term. We work in a seasonal industry, and the value driven by customers, it differs at different points in the year, and this will be reflective of their motives for purchase. At different times in the year, they'll be buying for different reasons and through different channels and through different mechanisms, perhaps relying on credit to more or less extent at different points in the year. We too alter our promotional activity throughout time. So what we do in the guardrails when setting these levels of investment is we're very mindful of that, and this process acknowledges that differential over the year and calibrates accordingly. The output, the setting of these targets, it's not a one-size-fits-all solution. We determine these targets across various layers or dimensions. So picking up where I think I left off, so I was mentioning that we track and we will change spend accordingly if we see throughout the month that we need to either pull back or invest more. And finally, this all gets reported at key trading forums on a monthly basis. So now we've embedded the use of these predictions within our monthly marketing process, I think it would be really good to move on to the size of the change that we've generated through this piece of work. So we have achieved a lot, and this has been recognised in our most recent set of results, in fact this month, again by Steve, our CEO, where he states that the use of our AI model has been crucial in determining and removing our unprofitable marketing expenditure. So to bring that to life a bit more, in the financial year up to March 2020, we managed to achieve a 13% reduction in our marketing budget. And within that, we also reallocated spend using this model from lower customer value driving channels to higher value channels. But it doesn't end there. In the financial year up to March 2021, we needed to further reduce our marketing expenditure, in part driven by the pandemic. And what this model has enabled us to do is to determine the lowest profitability channels and remove further spend from there. And we've managed to achieve a reduction in spend of £60 million. So this model has been amazing in driving that change. And then finally, the recognition of this model has culminated in us winning the Draper's Best Use of AI Award 2020. So for those of you perhaps less familiar with Draper's, they're an institution that track and report on changes within the fashion industry. And this is a very prestigious award for us to have won. We're a really even more excited and pleased to have won it because the judges' comments acknowledged not only the fantastic data science work that underpinned all of this, but also the fact that we'd brought the model to life and had really embedded it in our commercial success. So linking right back to the beginning where Adam outlined our 3 rules for success, we truly believe that this project demonstrates how we've hired right and worked collaboratively with our colleagues within our team and outside with our colleagues in other departments. We've dreamt big. We've delivered a solution that covers every customer and it incorporates all the elements of our business model. And then finally, we've shown how we've delivered value through the dramatic cost savings that we've managed to achieve through the implementation of this model. So I'd just like to wrap up and say thank you everybody for listening to us today, and thanks to my co-speakers, and thank you also to Data Idols for giving us the opportunity to share this piece of work with you all. And I'll hand back to David.
Perfect. Thank you very much, Laura. I absolutely love that from you and everyone else there from M Brown. And I think actually it'd be a good point to, Laura's run away, but it'd be a good point to get all of you to come back actually, and we'll have a bit of a catch up and talk about some of the Q&A. So yeah, please come back. It may also be a good time to stop sharing the screen as well. And we'll go into the questions, but I think for me it's always really nice to look at a real world use case. There's been such clear value delivered from a team and from a project, and perhaps shouldn't be saying it if the CEO's watching, but you probably all deserve a pay rise after that. You've delivered great value for the business, which is great to see. We will get onto the Q&A. There's been a number of questions coming in. If anyone at home does have more questions, please do fire away. We've got 10 to 15 minutes to go through now. So I think I'll maybe just start off with a question of my own before we get into the ones from the audience there. And it's probably best to direct to you, I think, Laura. But with hindsight, there's been clear value delivered from the work that you've done. But I'm just interested to know what it was like when you were first kicking off the project and first had the idea. Were there any particular barriers that you came up against in terms of getting this off the ground and ultimately getting it implemented?
Okay, thank you. That's a really good question. So it's probably best to answer that by talking across our path to implementation. So I think the key was to work with our stakeholders and start small. Going back to some of the themes that we used in the presentation. So we didn't just launch on all our brands. We built up brand by brand, and we've added those layers of sophistication to the guardrail solution over time. We've taken our stakeholders along with us on a journey. We've shown the predictions versus the actuals to build in that trust and use to give the use of the model. And finally, I think we've also been aided by the impetus of change and sort of like the direction from top down to drive these marketing efficiencies. I mean, I'm not going to say it was completely plain sailing. There were always bumps along the way with implementing this kind of thing. But I think the key to it has been collaboration with our colleagues in our paid media team, who've been fantastic.
Perfect. Yeah, teamwork makes the dream work. Hey, I'll get shouted at by my team for saying that on a webinar, but I do say it a bit in the office. Yeah, again, fantastic. And yeah, it's nice to see this data-led culture. And one of the questions that's come in from Chris Dunhill there is, where do you think that's come from? Within the business. Is it coming from the data team leading it out, or do you think it's coming from other sort of senior stakeholders? And I'm not sure who'd be best to answer that, whether it be Laura or Adam or anyone else.
I can start, and Adam, you can maybe add to it. I think to some degree, if we go back to how Adam described in his introduction, we've always been a data-led company because we've had limited stores. We have got to know our customers through our data, and that's permeated across the whole business. So it is sort of like built into the DNA of perhaps all the people that work at M Brown. But supplemented with that, we do go out and shout a lot and try and get ourselves heard.
Perfect. It's good to hear. Adam, was there anything to add from your side, from that side of things?
Yeah, sorry, I had a technical issue there. I missed the beginning of the question. You could repeat.
We were talking about it's great to see such a data-led culture within the business, and we were keen to know a bit more, where you think that's come from. Has it been driven outward by the data teams, or does it come from other senior stakeholders? Yeah,
I mean, to be honest, I think it's a mix of both. There's a lot of initiatives within the team to build up a data community, and actually one of the things we do as a business is work with a company called Dataled to run a data fellowship, which means that people across the organization in every role, whether it's logistics, people, team, marketing, finance, undertake a 1.5-year program to learn about data science and data analytics. As part of that program, we work with those teams, so we'll mentor people on that program, and after the program they also join our data community, which means sort of sharing some of the work that we do together. So I think that kind of initiative really helps to get sort of traction in building out the broader data community and having that conversation across the business. So a lot of that's come from the team. We do a lot of work. We put a lot of emphasis on shouting out about the stuff that we're doing. So pre-lockdown, that included having regular monthly sessions where we'd present our work exactly how we are today and just invite people from across the organisation. So I think it's doing everything that we can to shout out about what we can do with data, where the opportunities lie. Equally, I said at the start, I guess in part this is through the heritage of the organisation, that it is very genuinely a business that's had to get to know its customers through data. And I've seen that over the years. I started my career out in Brown about 15 years ago, and I can see over the last sort of 15 years or so a massive step change in how people use data in their day-to-day roles. And so I think that's like general industry change, that just a lot of roles use data now and dependent on data. And obviously we do what we can to sort of push that agenda in terms of making sure people are clear.
Makes sense. Yeah, makes sense. And it's good to be proud of what you've done and shout about it, I think, sometimes as well, eh? So we've had a couple of comments coming in on the chat, which is great to see. Helene is saying congratulations with your award. Andrew Logan, great presentations, great teamwork, data science end-to-end in the real world. And Chris Shumba, thank you for the presentation, amazing work and value. And we'll jump over to the Q&A and fire through some of these now. You can read along yourself at the same time, but we'll go to the first question from Eugenio. It's actually the second one down in that list. How many months do you consider in your customer lifetime value model to compare actual value versus predicted, i.e. summing all purchases a user will do in the next X month? What is X? What are the time frames that you're looking at?
So several different time frames. We've got different customer value models for different time periods. So we have a view of what a customer will deliver for us in 2 years versus the first month. So yeah, several.
Perfect. And the next question there from Hazel. We've got a couple of questions from Hazel, so we'll go through both of them actually. Hazel says, I'm a student who's interested in applied data science in retail. I'm wondering if you predict churn, and it is connected with the customer value prediction. How is your CLV model different from using survival analysis?
Yeah, so in terms of predicting churn, I think that's oh, you want to answer? Oh, right, sorry.
That's me. Ignore me.
I'm like, oh, you want to answer. So in terms of predicting churn, that's kind of the aim of the probability model, is to predict whether a customer will purchase again within so many months in the time frame. Mm-hmm. And then, is it different from using survival analysis? So I'm going to hold my hands up. I'm not an expert on survival analysis, but I think it's different in that in the features in the model itself, that's when we use the time component. So when did they last purchase? When did they last do that? So that's kind of, we've incorporated that as a feature rather than what I assume is in survival analysis methods.
Okay, thank you very much. And we'll flick back up to the top question there again from Hazel. Do you evaluate the model in time series if the feature importance shifts in different time period?
Yeah, so that's also a really great question. Thanks, Hazel. So definitely, the time when a customer joins us and the time at which we produce these predictions is really important. So for example, when we think about our peak period around Black Friday, that drives a different type of customer to someone that we see in summer. So we do have to make sure that we're evaluating it at different time periods for sure. Yeah.
Perfect. Thank you very much. Jitendra is asking, how often do you retrain your models?
So we'll be training these. We'll be training all of them within. I don't know what I'm saying anymore, but we'll be retraining these every week. Yeah.
Perfect. Thank you very much. I'm keeping these coming short and sharp, to be honest, when we've got limited time. So if you need to take a breath, by all means do. Question that's come in here from Paul Kelly. Paul's interested to know, do you break up the marketing spend into different categories? And if so, do you similarly identify users based on what type of marketing approach brought them in?
Yeah, jump to that, Laura.
Yeah, so I assume by different categories, I think we must be referring to different channels there, then we would term it channels. Yeah, so we can identify how a customer has come to us initially and continues to transact with us. And we do see that such customers bring in differing customer values, not only to channel, but to some degree to the channel, but also through other features as well. Does that answer the question?
Hopefully? Yeah, perfect. Thank you very much. Definitely. We're going to keep going with the questions from Chris Shumba. Probably for you, Nikos, actually this one. So that he's asked two questions. I'll go with the second one. Will incorporating serverless infrastructure, AWS Lambda step functions be something the team will look into in the future?
Yes, so we have different projects that run in our team. So for example, in pricing, we take advantage of serverless technology like Lambda, etc. Yes, so mainly we have this architecture in this project because it is a batch process. So we just want to run our results once per week. So we use Airflow and it's a batch process. That's the main reason.
Perfect. Thanks, Nikos. And actually, Chris's first question there as well is relevant. Do you have any real-time models, and do they follow the same architecture?
So, yeah, so the answer is the same, because this is a batch model. We just run it once per week. It's not live in an endpoint. We are working on several projects currently, and we are testing SageMaker solutions for live models, and so deploying models in endpoints. And yes, we are in a development phase of projects.
Yeah, I think that real time is kind of that's the next one that we're cracking, like kind of continuous ML and real time deployment. So we've been working with Amazon, so our colleagues at AWS on drawing in some of their engineers to get support on rolling this out actually, and looking at different options for deployment this way. So it's, I think for us, we've been on a journey over the last couple of years in sort of migrating to AWS, building up the team's capability, changing our ways of working around that. And I think looking ahead, this is probably the next step for us is that continuous ML and real-time deployment.
Perfect. Yeah, there's always more to be done, eh? Sadly. There's a few comments coming in through the chat, just people saying thank you. So thank you for commenting at home. It's nice to know that people are watching along. So John Neary, Steve Miller, Chris, Maru, all saying thank you for your time. David Fountain, fantastic presentation, really interesting, thanks. So I'm a little conscious of time. We're getting towards that 2 o'clock, but there is quite a few questions left. So maybe if we could take 2 or 3 more questions, just a little run over by a couple of minutes, if that's okay with you guys. The question there from Michael Bateman. Michael was asking, have you considered using causal modelling?
I'm not sure what he means by that.
Okay, we'll move on. Thank you. Ben Henschel, why include the cost of good in LTV if you want to know what the total amount someone is willing to spend, unless one models for profit, but surely the profit margin is not as dependent on the customer as in on the product they bought?
Yeah, so that's a great question. I think maybe that's where so originally we showed that there was the demand and then returns and then all the subsequent costs. So the model I talked through was just the demand, but ultimately because we want to understand how profitable a customer is, we do need to understand the cost of those goods as well. And so it is, we didn't talk about it now, but it is important that we understand what type of products that customers are buying, so that we can have a good cost price prediction as well.
Perfect. Thank you very much. I'm going to jump to the question from Guy, basically saying, great presentation, thank you. What were the challenges faced when first defining the scope of the model, and how many models are part of the overall solution in production?
So I think the initial challenge really in terms of the model was how to limit the scope, because there's so much that we can do with this. So I think Jane talked about this a little bit, but in the end we ended up limiting the model to new customers, and I guess limiting the scope of what we're trying to do with the model, and just in predicting the target variable outright rather than trying to break down into the component parts. So there's quite a lot really early on about, if we're looking at new customers, then big challenges. We don't know much about a customer at a point in time, so it's challenging to sort of how long do we wait that gives us an early enough indication of a customer's quality after they've joined us, but a robust enough prediction that we can have confidence in that in that prediction. If you think about the application that Laura's talking about and making fairly strategic decisions about where we spend marketing budgets, some latency is allowable basically in drawing that conclusion. So we allowed a little bit of time before we made a prediction, but that's really where some of the early complexity was in the scope. How long do we wait? Who do we build this prediction for?
Perfect. Yeah, makes a lot of sense. I think in terms of, as I say, conscious of time, I think we are going to have to wrap things up there. We do try to keep these sessions to that 1 hour so people can do it over at their lunch hour if they're UK based anyway. We do store all these questions, so I'll maybe follow up with you, Adam, afterwards. We can go through them, maybe even turn them into a blog post or something like that, and follow up with any ones that we didn't get to. I think I speak for everyone when I say it was a very, very enjoyable presentation. Lots of fantastic content and takeaways, and you can tell by the number of questions coming in. Everyone at home definitely enjoyed it as well. So I guess I just want to wrap things up by saying, thank you very much for giving up your time. I know it takes a lot of effort to prepare all the content, and I know you guys were practicing behind the scenes to make sure it all ran smoothly. So really, really appreciated as a community. Thank you for your time, and thanks to everyone at home who's watched along with us as well. So thank you very much, and hopefully we can check back in with you guys later on in the year and see how you've been progressing as well.
Absolutely, thank you.
Perfect. Thanks everybody. We'll see you at a future event soon. Bye bye.
Thank you.